Hello everyone, in this video we'll see binary trees lowest common ancestor. We are given one binary tree and we are given two nodes data, so like 8 and 9. We have to find the lowest common ancestor for these two nodes. But these two nodes, the answer is 5. When we given 6 and 9, the lowest common ancestor is this 2. So here is our node definition as data, and right and left pointer are there. So we are given one more integer n1 and n2. We have to find what's the lowest common ancestor is. This is the most frequently asked question during the programming interviews. So we'll see how to solve this problem. Here's our code snippet, namely LCA, and it expects 3 arguments: node, n1 and n2. Node is the root node that we have to pass, and n1 n2 are the two integer nodes data. Okay, in first line, if the node is null, in these cases, like in 6 is there is no node attached to it, so these kind of conditions we just return it. So we have to return that, or else we have to first of all find out that node. So the node, whatever it's coming, if it is matches with either n1 or n2, we'll return that, because that return node will be reused in the below lines of code. So this first line is for whenever node is null or it matches with either n1 or n2, we have to return that node. Okay, now from the beginning, from the starting node, we have to travel deeply inside the left and right. So we go to the left and find out that n1, and we go to the right and find out that n2. This will be mixed up also. Here you can find n2 and here you can find n1. So that swapping also can be done in this one. So once we find out that n1 and n2, we can assign it to the left and right. So by the time when left and right both are not null, we have to return that. At the minimum point of level, here it is returning that node as a not null one, and here also it is returning as a not null one. So this is the nearest place these two nodes will meet. So we have to return that. This condition return if the left exists or right means when you have this one node, you could find out, but one node is not there. It is nowhere it exists, means you couldn't find out that node, means it is returns only null. By that time you have to print only this 6, because that node is throughout the tree, it's not found out. Okay, in this condition, the reverse also you can take as so n2 is there but n1 is not there. In that condition, so you have to just return whatever is not null, you can just return that. If both are null, you have to check that condition, but this problem guarantees that at least one node will be there, and both of the nodes also many times it will be there. Okay, we can see those things with an example of this binary tree. Here you have 50 and 60. So here this 10 will goes to the function first, and it checks for whether this matching either null or n1 or n2. No, it's not, so it will go to the left direction, and it will go and checks to the here. It is also returned, it is null returned, and when it goes to the right, it's matching. So this 50 with the nodes data will be returned. Here you have returned with this 50. So this node here, it returns as 50, and here at this line, either left or right, when counters comes to this one, this node carries some data. So this 50 only propagated to the upper level. So here also this 50 goes, and when comes to the right side, it goes to the 30, and it goes to the left side. Here it left exists, so it propagates this 60 here, and here nothing comes, so here null only comes. So this 50, this 60 will will be in a higher weight and it goes here. So at node 10, this line statement will be executed. Left and right both are not null. By that time, this node 10 will be returned. So this will become a lowest common ancestor for these two nodes. And that's our answer here, you can see. Okay, now we see this one also. When two nodes are like adjacent nodes or on the same path, whatever nodes appear on the top level, that's the answer. For the example here you have 40 and 20, so the lowest common ancestor is this 20 itself is the ancestor for this 40, so this answer is 20. And for this node, you can see the 60 and 70 here, the nearest node you can see is 50. When one node is absent or node is not there, like 140 and 30, if we are giving this kind of data, whatever node exists we have to return that time. Only 30 is there means only 30, if else 140 is there means there only that one. If both are null, that's a separate case. Okay, now we switch back to Visual Studio Code and we'll write this name code snippet and we'll check whether this code is executing perfectly or not. Here I have necessary using statements and imports, and here followed by I have node definitions like int data and left and right pointer, and followed by the constructor for this node. And in main function body I have these three tree representation in coded format, and I'm going to use this data for my test cases. Now we'll write node star, it will return node, so that one, and find LCA, it expects the node should be there, so, and then int n1 and int n2. Inside of this, if this root is null that time, and this roots data equal to n1 or roots data equal to n2, I have to return that. How to find the left root and right root, so L root equal to find LCA roots left comma n1 comma n2. The same thing for right also, so R root, and here you have to pass the right. If both are L root double and R root, then you have to return that root, or else you can write return L root, that time it exists, you have to give this L root, otherwise R root. Okay, now we executed cout n LCA. In LCA I have to pass this n, and I have to pass this 50 and 60, how to print that data. Okay, now this is, and I do this for this 20 and 40, and I have to pass m, here also m, and here I have to give this 60 and 70, 60 and 70, y and y. Okay, now run the code. 10 20 50, here 10 20 and 50, so we got the answer as perfectly. All test cases are working perfectly, And I hope you understood this problem and solution. And thank you for watching this video. We'll meet in the next video.